Okay, we have here the 2016 Queensland Senior External Exam Physics paper. This is paper 1. It's part A, section 2, short response, question 5. First thing we do is we read the question carefully. Two in-phase point sources A and B generate waves as indicated in the diagram below, in which the full lines indicate crests and the dotted lines represent or indicate troughs. Comment on the difference in path length between the lines AP and BP with reference to the wavelength of the waves and the type of interference produced at point P. Right, we've read the question once. Now we reread the question and we identify the important pieces of information. Question 5. Two impulse point sources A and B. So we're talking about the points A and B, so we identify them in the diagram, like so. Generate waves as indicated in the diagram below, in which full lines indicate crests and dotted lines represent troughs. So that's very important that we understand that the full lines are crests and that the dotted lines are troughs. Of course, in your standard wave pattern, this is a crest, this is a trough, and so here at the top we have crests, and here at the bottom we have troughs. Crests and troughs are points of maximum displacement from the rest position. The crests are positive or upward displacements, and the troughs are downward or negative displacements. We comment on the difference in path difference between the lines AP and BP. So it's important that we identify the line AP. So we have the line AP as marked, and we have the line BP. And we have the line BP as marked. So there we have line BP, and here we have line AP. Now we want to talk about these lines with reference to the wavelengths of the waves and the type of interference produced at point P. So the wavelength is the distance between crests. It can also be determined the distance between troughs as well. So in this particular point, if we have a look at the line AP, we start off at A here. A is on a solid line, so therefore it is a crest. Then we go trough and we go crest, so there's one wavelength. Trough, crest is two wavelengths, and then we go into a trough. So from A to P is 2.5 wavelengths. 2.5 wavelengths. To write that as a vulgar fraction, we make it 5/2 on lambda. Now we have a look at from B to P. B is on this line here, which is a crest, and so we go from a crest to a trough to a crest, that's one wavelength, and then we go from a trough to a crest, which is two wavelengths. So the line BP is two wavelengths. Now we can write that therefore as 4/2 wavelengths. Now the question in particular asks us to comment on the path difference. So the path difference, this is what the question is actually asking us to calculate, is the value AP minus BP. Now in each one of these, that's the line, and so we have 5/2 lambda is our path A to P, and we subtract that from BP is 4/2 lambda, and so therefore we have a path difference of lambda on 2, or half a wavelength. Now that we've calculated the path difference, we need to talk about the type of interference produced at point P. Basically, when you have a crest and a crest, that gives you a double crest. That's the principle of superposition. When you have a trough plus a trough, that is a double trough. Both of these are called constructive interference. Destructive interference is where you actually have a crest plus a trough, and that gives you the flat water. That happens when they are out of cycle by half a wavelength, or the path difference is lambda on 2. So because the path difference, anytime the path difference is n lambda on 2, which is half a wavelength, or 1.5 wavelengths, or 2.5 wavelengths, where n is at the integer, that's going to be destructive interference. So we've gone through our problem where we've done our evaluation. Now the last part is to actually check to see whether our answer makes sense, whether we've actually answered the question. And so we have a look, comment on the path difference between the lines AP and BB. The path difference here is half a wavelength. And we've done that with reference to the wavelength, yes, and the type of interference. So the type of interference is destructive. So we'll put here the type of interference is destructive interference.